Today we will start our discussion from heading Mendeleev's contributions to the periodic table. So the first term, Mendeleev. Mendeleev was a Russian scientist, a Russian chemist, and his full name was Dmitry I. Mendeleev, and he has given a periodic table in year 1869. So Mendeleev's contributions, basis of classification of elements. So Mendeleev has given basis of classification of elements. Mendeleev arranged elements in increasing order of atomic weights in the form of a table called the periodic table. So students, periodic table is a table in which elements are arranged on the basis of their atomic weight by Mendeleev. Then this arrangement had elements with similar properties appearing at regular intervals. So when Mendeleev arranged elements on the basis of their atomic weights in increasing order, he got a table which is known as periodic table, and in this table similar properties of the elements are appearing at regular intervals or after a definite time. This phenomenon is called periodicity of properties. So reoccurrence of the properties after a regular interval is known as periodicity of properties. Properties which repeat themselves at regular intervals are called periodic properties, and the properties which are showing periodicity are known as periodic properties. So there are number of periodic properties of elements, and out of those few important one are atomic radius, ionization potential, electron affinity, electronegativity, valency, metallic and non-metallic character, etc. Now next heading is Mendeleev periodic law. So this is the law on the basis of which Mendeleev has arranged elements in the periodic table. So according to this law, the physical and chemical properties of elements are periodic functions of their atomic weights. Okay students, so according to Mendeleev, atomic weight of an element is its fundamental property, and when we arrange different elements in the increasing order of their atomic weight, then we found that elements with similar properties reoccur after a definite time intervals. Okay, so means properties of elements are periodic functions of their atomic weights. So from this law we can conclude 2 points. According to the first point, the physical and chemical properties of the elements depend upon their atomic weights. And second point, the dependence of physical and chemical properties of elements upon their atomic masses is periodic. Okay students, is periodic. This means that if the elements are arranged in the increasing order of their atomic masses or atomic weights, the elements with similar properties should reoccur after regular intervals. Okay students, so here part of Mendeleev's periodic table is given. Mendeleev's contributions. Elements were arranged in increasing order of atomic weights in horizontal rows called periods and vertical columns called groups. So as you can see from here, these are the horizontal rows. These rows are known as periods and these vertical columns are known as group. Second point, elements which are similar with respect to their chemical properties are grouped together and have atomic weights of nearly the same value. So all such elements which are having similar properties are grouped together in the form of a group. Okay students, so in a particular group, the elements which are placed are having similar properties. Then the third point, elements in the same group had the same valency and similar chemical properties. So in a particular group, all the elements with same valency and same chemical properties, because chemical properties are depend upon valency. So in a group, if all the elements are having similar valency, means their chemical properties will also same. For example, in the first group, hydrogen valency is 1, lithium valency is 1, sodium valency is 1. So due to the similarity in valency, they will have almost similar chemical properties. Then based on the periodicity of properties, a number of gaps were left in the table for undiscovered elements. Okay students, so at the time of Mendeleev, just 65 elements was known, and that is why he left several gaps in the table for the unknown elements and predicted their properties on the basis of the properties of the other elements present in the same group. Okay students, later on, when these elements were discovered, their properties were found almost similar to those predicted by Mendeleev. For example, elements which are now discovered are scandium, gallium and germanium. And these elements was originally called as eka boron, eka aluminium and eka silicon respectively. So the elements which were known with these names, now we are knowing these elements with the help of these names. Okay, and the properties which was given by Mendeleev on the basis of his periodic table was found almost similar for these all elements. Okay students, the next point, the properties of the undiscovered elements left in the vacant gaps was predicted. So as I told you already that Mendeleev has declared properties of unknown elements also on the basis of his periodic table. Now last point, incorrect atomic weights of some of the arranged elements were corrected with the knowledge of the atomic weights of the adjacent elements. Okay students, for example, atomic weight of beryllium is earlier known as 14.8, or you can say 14.8, or you can say 15. But Mendeleev has characterified the atomic weight of beryllium, and according to him, atomic weight should be 9. Atomic weight of beryllium should be 9. And this correction he has done on the basis of distribution of elements in his periodic table. Now next heading is defects in Mendeleev's periodic table. The first point is anomalous pairs of elements. So in certain pairs of elements, having higher atomic weights have been given positions before the elements having lower atomic weights. For example, cobalt and nickel. Cobalt atomic weight is 58.9. It is higher in comparison to atomic weight of nickel, which is 58.6. But cobalt is placed first, and after that nickel is placed in Mendeleev's periodic table. This placement is wrong according to Mendeleev's periodic law. Okay, students, but this mistake can be rectified if we place these elements or such type of elements on the basis of their atomic number. So you can see that cobalt with atomic number 27 and nickel with atomic number 28. Okay, so atomic number of cobalt is less than atomic number of nickel. So on the basis of atomic number, this placement of the elements means placement of nickel after cobalt can be justified. The next point, position of rare earth and actinides. Okay, so these are the elements and the position of these elements could be justified only if arranged according to their atomic numbers. Okay, students, so we cannot justify position of these elements on the basis of atomic weights. Now last point, position of isotopes. So in Mendeleev periodic table, isotopes of an element should be placed at different places. Why? Due to their different atomic masses. And this will be anomalous because isotopes possess similar chemical properties. So means they should have same place. But if we are placing according to Mendeleev's periodic law, then isotopes will have different places in periodic table. So again this will be not possible for the isotopes because they are having similar chemical properties. Okay, students, so these are some defects in Mendeleev periodic table. Thank you.